Okay, so for question 7, question asks, find constants a, b, and c such as the graph of f of x is equal to x to the power of 3 plus ax to the power of 2 plus bx plus c will increase to the point minus 3, 18, decrease to the point 1, negative 14, and then continue increasing. First thing you want to do, determine what the question's asking you. So here they want us to determine the constants a, b, and c of this graph right here. And the information that they give us is that the graph will increase to the point negative 3, 18, decrease to the point 1, negative 14, and then continue increasing. So what does that mean? Let's get a visual of this. So we have said graph, and we know that it increases to the point of negative 3, so, and 18. Decreases to the point of 1 and negative 14. And then continues to increase. So we have maybe something that'll go like this. It'll decrease to this point and then continue increasing. So what does that mean? Well, what's not said in the question, but you can assume by the visualization, is that this point here and this point here, well, negative 318 is our local max, and 114 is our local min. Okay, so it increases, decreases, and then increases again. So we know with these points as well, this gives us an x value, and this gives us a y value of our main function f of x. So I'm going to plug those in, and we'll see what it gives us. So we have our f of x is equal to x to the power of 3 plus ax squared plus bx plus c. And then, well, we know that it's equal to when x is equal to negative 3, we know that our f of x is 18. So we're going to do 18 is equal to negative 3 cubed plus a negative 3 squared plus b plus c. So negative 3 cubed, well, that's going to give us negative 27, plus, well, negative 3 squared is going to give us 9, so 9a, negative 3, so that's minus 3b plus c is equal to 18. And then I'm just going to try to push all the numbers to one side. So negative 27, I'm going to send it to the other side and do plus. So that gives us 45 is equal to 9a minus 3b plus c. And we'll just call that equation 1 for now. We're going to do the same thing for our minimum. So f of x is equal to x cubed plus ax squared plus bx plus c. We know that it's equal to minus 14. So we have 1 plus 1 times a plus 1 times b plus c. So we have negative 15, so I'm just sending this over that way, is equal to a plus b plus c. That'll be our equation 2. So right now we have 2 equations, 3 unknowns. So there's not much that we can do with it. So we're going to have to go deeper. Now we know that a critical point, well, we can call these 2 points critical points, right? And we know the critical points are found when our derivative is equal to 0. So that means that when x in our derivative is equal to -3 or equal to 1, it means our whole function of the derivative is equal to 0. So let's find the derivative of our function. So let's find the derivative of our function. So we have f of x is equal to x cubed plus ax squared plus bx plus c. So f prime of x is equal to 3x squared plus 2ax plus b. So we found our derivative is equal to 3x squared plus 2ax plus b. And now we know that our critical points are at x is equal to -3 and x is equal to 1. So since we know those are minimums and maximums, we know that f prime of x is equal to 0 when x is equal to -3 and x is equal to -1. So let's use that information to create maybe a system of equations in order to solve for our variables. So let's do, so f prime of -3, well, it's equal to 3 times -3 squared plus 2a times -3 plus b. And we know that f prime of -3, since it's a minimum or a maximum, it's going to be equal to 0. So we have, and then this is 3, -3 squared is 9, so 3 times 9 is 27, plus, well, it'll actually be minus because -3 times 2 is -6a plus b. So that'll be our equation number 3. And then we'll do the same thing for when f prime of x is equal to 1. So we'll plug in 1 as our x. So we have 3 times 1 squared plus 2a times 1 plus b. We know that's equal to 0, so we have 3 plus 2a plus b, and that'll be our equation number 4. All right, so now we have two equations with the f primes and two unknowns. So we have our a, b here, and we have our a and b here, but we have one equation, two equations. So now we can create a system of equations to solve. So what does that mean? Well, I'm going to do number 3, equation 3 minus equation number 4. So what that looks like will be that you're going to write your first equation. 0 is equal to 27 minus 6a plus b. So that's our equation 3. And our second equation, 0 is equal to 3 plus 2a plus b. That'll be our equation 4. So if we do 3 minus 4, well, that's we're going to put a minus here. 0 minus 0, 0. 27 minus 3, 24. Minus 6a minus plus 2a, so that's going to be minus 8a, and then b minus b, well, that's 0. So now we have 0 is equal to 24 minus 8a. So I'm going to send the minus 8a to the other side, so I'll have 8a is equal to 24. Then I'm going to divide both sides by 8, which will give us a is equal to 3. So now we found the constant a value. So how are we going to find the constant b value? Well, we're just going to plug it into equation 4, let's say, and solve for b. So a is equal to 3 sub into equation number 4, which will give us 0 is equal to 3 plus 2 times 3 plus b. So we have 0 is equal to 3 plus 6 plus b. So we have, so 3 plus 6 is 9. I'm going to send it over to the other side, so it becomes minus 9 is equal to b. Now we have our A, we have our B. How do we find our C? Well, we're just going to plug it into our equation number 2. Since we have a C value here, we have A and B. So we found those. So now we can plug them in and solve for C. So sub A is equal to 3 and B is equal to -9 into equation number 2. So -15 is equal to A plus B plus C. -15 is equal to 3 minus 9 plus C. 3 minus 9 is -6. So -6 plus 15. Oh, sorry. -15 plus 6 will give us -9 is equal to C. So what does that mean? All that to say that our equation f of x is equal to x cubed plus ax squared plus bx plus c. Well, now we have our values of a, b, and c, so we just have to plug them in. So we have f of x is equal to x cubed plus 3x squared minus 9x minus 9. And that's our answer.